Very good morning, students. We are discussing chemical kinetics, and I have already derived zero order reaction, first order reaction with half-life period. After that, in your syllabus, we have to discuss the effect of temperature, catalyst and activation energy on the rate of reaction. Yes, well, everybody knows that the effect of temperature on the rate of reaction. So dear students, with rise in temperature, rate of reaction usually increases. It is found that with every 10-degree rise in temperature, rate of reaction becomes twice or even sometimes thrice. Just to imagine, if you want to decompose, for example, dinitrogen pentoxide 2 times, if I want to decompose at 0 degrees Celsius, 25 degrees Celsius and 50 degrees Celsius. Just to imagine, at 0 degrees Celsius it takes 10 days to complete the reaction. Just to think over it. Once you increase the temperature 25 degrees Celsius, it will take 5 hours to decompose dinitrogen pentoxide. But at 50 degrees Celsius, it takes experimentally 12 minutes and it forms N2O5 undergo decomposition to form N2O4 2 times plus O2. That is why we would like to say, with rise in temperature, rate of reaction usually increases due to increase in the kinetic energy. Experimentally, with every 10-degree rise in temperature, rate of reaction becomes twice or even thrice. Thus we can say that the ratio of the rate constant. Hence, we can say that the ratio of the rate constant at two different temperatures differing by 10 degrees Celsius is called, what you say? It is called temperature coefficient. Generally, these two temperatures are taken as 298 Kelvin and 308 Kelvin. Hence, temperature coefficient is defined as temperature plus 10 upon T. Actually, in numerator, what we observe, once you increase the temperature by 10 degree, therefore 298 plus 10 upon 298, that means 308 upon 298. At the time, rate of reaction becomes twice or thrice. Number of collisions per second per unit volume is called collision frequency constant and denoted by Z. It is found that Z is directly proportional to square root of temperature. Dear students, here Z is the collision frequency constant, and it is observed that number of collision per second in between two reactants is found to be 10 to the power minus 15 per second. So Z is directly proportional to the square root of temperature, and Z at 308 Kelvin equal to under root 308, Z at 298 Kelvin under root 298 Kelvin, and hence the ratio between these two temperatures 308 upon Z 298 Kelvin equal to under root 308 upon 298, that is found to be 1.0 or 102 upon 100. At the time the rate of reaction becomes twice or thrice. So it is what 100 to minus 100, that you can say rate of reaction becomes twice. With every, again you have to increase 10 degree, it becomes quadruples, octuplets. So the way rate of reaction going to increase. Dear students, now plot the graph between, you can see temperature in Kelvin, and this side you write fraction of collision. Fraction of collision. This side is the reactant and this side is the product. So here it is the reactant forming activated complex to form the product. So here it is without the increase of the temperature, this dark shadow representing like this, it is the reactant, it is the product, and this is the, what is that? Activated complex. At the time it is generally T, but once you increase the temperature, another fraction of molecules are obtained, and that is what, another shadow representing the another fraction of the molecules, and this shadow is 10 plus T. At the time activation energy becomes smaller, and but beginning it is the activation energy, the energy which is needed, activation energy 2 and activation energy 1. So it is needed to form the intermediate called activated complex. The energy which is needed to form the intermediate, or rather we can say activated complex, is called activation energy. I will discuss later on. So the way what we have observed, without temperature graph is like that, but if we increase the temperature by 10 degree, activation energy becomes smaller and rate of reaction becomes twice. So this is the first line and this is the second line. This is what actually, this side is the reactant and this side is the product, and this is only at T, but this line it is T plus 10. So this is the effect of temperature on rate of reaction. Is it clear?